Yeah, so it says my
Okay,
own is being
good to go.
recorded.
All right, sounds good.
All right. Thank you everybody for being here today. We're going to do something really special. This is the Starburst Foundation that Paul Laviolette started. And we have Brandon, the CEO of the Starburst Foundation. We have Amber here, and we have Legia. And what we're going to do is we're going to go through 80 pages of handwritten notes that I did in the spring of 2018. And in the spring of 2021, I started releasing these to the world, and they were literally sent all over the world to hundreds of people, including a lot of scientists. So what we're going to do is we're going to go through 10 pages at a time. There's 80 pages, so we'll do 10 pages today. And we're just going to go through stuff. And I think it's going to help people understand the electronics a little bit better, but then the actual, how do we make this stuff work, essentially. We dig really deep into it. So I'm really excited to get going with this. So at the very top, it says 100 kilowatt or kilovolts and heavy high K dielectric. And then there's a plus and a minus. Now that force arrow belongs to the drawing below it. So don't look at that force arrow. But on the next page, we're going to talk about how we use high K dielectrics. And when we apply high voltage to them, which is the 100 kilovolts, we can get a force in the negative direction set up. And this is the ponderomotive force. And this is the force that is quite literally awesome. So the next part of this is the G hill and the G well. And this is all from Paul Laviolette's subquantum kinetics theory. In this case, the gravity potential is on the right-hand side there. It shows the gravity potential and the force direction. So there is a coupling. There's an electrogravitic coupling relationship between gravitational mass. Gravitational mass is proportional to electric charge. So Brandon, let's talk a little bit about this, because I remember us talking about this, and you said that this is literally the holy grail of physics. Can you explain why you said that?
Yeah, okay. Well, let me just get up where Paul talks about that in his book. I've not got
Sure,
it up, but
that's
please.
fantastic.
Um,
Go right to the source, which is
uh,
beautiful.
um,
Because I remember having that discussion with you in our meetings probably a month or maybe a month ago or something like that. And literally, this relationship Paul came up with in 1994. So, and I've been involved, not involved with Starburst Foundation, but involved with subquantum kinetics since probably just after that time. At some point, I think it was. So it's been a long time. And remember also that Paul had wrote other books as well, subquantum kinetics books. All this information, or a lot of this information, comes from the Secrets of Anti-Gravity Propulsion. But I think Brandon is in the subquantum kinetics book right now, looking for where Paul talks about this. And it's good to know that.
so basically, it's to do with the coupling between mass and charge, or gravity and charge.
Yeah,
So he's given a simple equation or ratio where he's relating mass to charge. And in conventional physics, they don't do that. So mainstream physics, conventional physics, they don't he's showing a relation between mass or gravity
yeah,
and charge. So he's saying how they relate to each other. But that's what they're looking for. The holy grail of conventional physics, to find quantum gravity. How
exactly.
electrogravity.
Yeah,
Einstein was looking for the connection between electromagnetism and gravity, and he couldn't find the connection. So in this
yeah,
simple equation, because they're not using subquantum kinetics, here we're using standard physics, so they have different rules.
yeah,
We're losing
exactly.
subquantum kinetics, so we can. So Paul's just showing it in quite a simple way with a different framework, subquantum kinetics framework. So let me see if I can find it where he says that.
Exactly.
Um, so, yeah,
And in while Brandon's trying to find that, I'm going to read
here we go. I
on.
got it here.
Oh, you found it? Okay, perfect.
So, okay, we also know that the end plate of his gravitator measured 10 centimeters on a side and were separated by a 60 centimeter long dielectric that had a dielectric constant of K equals 26. Based on this, we can calculate that when fully charged to 150 kilovolts, its plates held a charge of Q equals 5.75 times 10 to the minus 7 coulombs. As he also given this Q equals voltage times
that's the amount of
dielectric constant,
charge.
permittivity of free space, area divided by diameter equals 1.5 times 10 to the 5 volts times 26 times 8.85 times 10 to the minus 14 farads per centimeter times 100 centimeters squared divided by 60 centimeters. Okay, so these are quite simple. I mean, they're not on a from a professional physicist. This is quite a simple formula. It's not.
Yeah.
It's not the very complex stuff of general relativity and quantum mechanics. If the above estimated positive or negative gravity potential deviation from the norm is divided by this corresponding source charge, we arrive at an electrogravitic ratio. So this is phi g, which is the Paul's gravitational potential, which in some quantitics is concentration per unit volume, and in general and in classical physics is joules per kilogram. So Paul alternates between the two. He sometimes uses he sometimes uses standard in order to sort of like work with the common units.
Yeah, compare back and forth. So Brandon, which book is this from and what page is that on?
So this is the SQK 6th edition, Subquantum Kinetics 6th edition, and it's page 428.
So for everyone that doesn't know, Brandon is just in the process of finishing the 6th edition, and then we're going to have it printed in hard copy with color pictures and everything, so that people will have all this information available. The book will be sold through the Starburst Foundation, I think. So let's move on.
It'll be sold on etheric.com bookshop.
Okay, perfect.
Well, we might have a link to Amazon, and also Lulu will have their own advertisement on their own website. But they'll sort everything out.
Yeah, exactly. So let's move on here. So depending on the polarity and orientation of the applied electric field, so we're talking about this ratio of charge to mass, this artificially induced gravitational acceleration may be engineered either to support or counter that produced by the Earth's field. So essentially, what he's saying here is we can engineer these, essentially their charge clusters, into a positive or negative potential, so that we can either push down to the Earth or use anti-gravity to lift us out into space. So let's go on to the next page, or it's actually the back page of my notes. For everyone that doesn't know, I only put numbers on the first front pages, and there's 40 of those, and that's why there's 80 in total. So there's no page numbers on the back of these.
I'll just go to.
So this next one, this is really kind of important because it was around October 31st of 2021. This exact theory that I'm going to read out here, I actually I gave this to Stevati Aerospace. So this is the theory of anti-gravity according to Paul, and something that I shared with Chris Beskar and David Wilcock and that. So I'll just read through. So subquantum kinetics predicts gravity has two polarities, which I was just saying before. Matter attracting gravity potential well. So either we create a well or like a hole in front of us, or the other part of it is matter repelling gravity potential hill. So in that first drawing on the first page, it showed the hill and the well, and essentially what happens is if it's a spacecraft, the spacecraft will actually fall into the well and be pushed from behind by the hill. So it is a lot like some of the things that they talk about in standard physics, but subquantum kinetics looks at it from a different sort of aspect. So we'll kind of carry on. So positively charged particles such as protons generate gravity wells. So essentially what we do is we shoot positively charged charge clusters. I don't know if protons is actually the right word there, but we use charge clusters and we shoot them forward, and then negatively charged particles such as electrons create the hills. So the forward part is the positive part, the negative part creates the hill that pushes from behind. So protons and electrons combine to form electrically neutral atoms. So this is important. The gravitational potent or polarities of the protons and electrons for the most part neutralize, but a proton's gravity well marginally exceeds the electron's gravity hill. So electrically neutral matter produces a small residual matter attracting gravity well, generating the gravity we commonly experience pulling us to Earth. So literally, he just described how gravity on Earth works, essentially. And again, it's got to do with these wells and hills and the ratios sort of between them and stuff. So I think we can go on to the next one, Brandon.
Yeah.
And this is going to get interesting, you guys, because now we're going to start talking about free energy. So this should be page 2. And it should have like a, yeah, that's the one. So this is an electrogravitic motor. Now, most people don't know that you can build magnetically inductive motors, but you can also build these. And they were called gravitator motor because that was the word that T.T. Brown used. So gravitator motor is a series of gravitator cells arranged in a circle, and they're self-excited, energized from the power that it generates by itself. And this was a 1934 patent. The patent number is there. Now the drawing is the round thing there that has an arrow. Yeah, can you go the other way, Brandon?
Yeah, that way.
Yeah. So that one. So the drawing there shows that arrow. Now, what we see there are there's positive and negative, and that would be the high K material. In between them, there's a different kind of material, and then there's another high K material. So if we apply voltage to the thing, like in the first drawing on the other page, 100,000 volts, this thing will rotate, and this thing will rotate indefinitely.
This drawing here?
Yeah, the very, very first drawing there. So what we're showing is we've got the heavy high K dielectric, and we're putting voltage on the plus and minus. And when we do that, that thing will move towards the negative side. So it'll move towards the left. And that's the ponder motive force. Now, how this thing works is literally what happens is when you apply that voltage to the negative and the positive on the wheel, it will rotate in the negative direction, and then the next cell picks it up, and the next cell picks it up as it rotates. So it basically runs itself. So what it says here is the spacing medium was less dense than the dielectric between each of the cells. So it's a different kind of material. So now cells
I have a
collectively.
quick question, if that's okay.
Yeah, absolutely. That's what we're here for.
Yeah. So does this need like an initial charge just to get it started?
Yes, yes, it does.
Okay.
Yeah, definitely. You have to basically just put the high voltage on it to get it going, essentially. And then once you've done that, then you can draw the high voltage not from the supply that you're using, but draw it from the actual energy that's being created by the wheel.
And some of the and also what's his name? T. Townsend Brown was actually using some quite low power. I
Yeah,
think he was
yeah,
using like 40 watts. That's what it takes to
yep.
run a light bulb.
That's
He was
that's a
using
great point.
he's levitating these objects with like 40 watts. You know, that's not
Yeah,
very much. That's not very much power. I mean, I'm not
that's a
sure.
great point, Brendan,
But he
because
was using a transformer to bring the voltage very high and the current very low.
yeah,
See, so
exactly. That's what I was just about to say. Because what we have to understand is, yeah, the voltage was extremely high and the current was extremely low. So, like Brendan said, it didn't require a lot of power. So the
the one thing
cells,
that Eddie, the one thing that Hakeem was asking me in that interview I did the other day
yeah,
was that he was saying he thought, is there a connection between free energy and anti-gravity? Could you say they are similar or the same in a
they're
way? So,
absolutely the same because like I was explaining, with the spacecraft, we create this well or hole in front of the craft and the hill behind it, and the spacecraft just wants to naturally fall into the hole.
mhm,
It's falling into the hole and being pushed from behind by the hill. Now, this wheel that's rotating is doing exactly the same thing. It's falling into the hole,
yeah.
and that's what keeps it rotating.
And
So the cells,
you could make devices that gravity free energy devices where you're using anti-gravity
yeah,
to generate energy to generate energy. You know,
that's
so
exactly what this is. So this was actually designed. The first number I've got in here was 1928, and then the patent was 1934. This is something that the Swiss have been using, have patented, have been using since then, literally. And their design is a twin rotor design, so it's a lot more complicated, but it's still high voltage because I can remember when I saw them talking about it, they said if you touch it, you will die, and that is the honest truth. If you're going at 100,000 volts, all it takes is I think 8 milliamps across your heart to kill you at that kind of voltage. So it's very dangerous. So I want to stress that part. So cells collectively generate unbalanced forces and thus provide rotation. Now, the wheel would rotate. The wheel would rotate in a state of free fall. So it's exactly what Brendan had just said. Now, this is where we're going to start talking about high K ceramic compounds. Now, T.T. Brown was using this stuff, and the stuff that he was using was generally very low. The number was 26 on the scale with high K. Now, as things moved along, then we found barium titanate, and it has a K factor of between 2,000 and 10,000. So it's much better. But nowadays, the best material that is commonly known, there are better ones out there, is barium zirconium titanate, or also known as BZT, and BZT has a
BZT.
K of 23,000. So yeah, if you just go to the make it so that we can see the bottom of the page, the
Yeah,
full bottom of the
yeah.
page. Yeah.
Um, Hang on a minute.
So sure.
just yeah, that's
So what that other drawing is just essentially showing the electrical connection between the positive and negative and how it has to be set up to make that wheel rotate. Now, some of this information, not all of the information in these papers is from Paul. Some of it is mine, and a lot of the high K stuff is mine. Um, there is a paper that is called Anomalous Behavior of Massive High K Dielectrics that I've seen and had access to, but it's still unclassified in its report by Brown. So even after going on 90 years or whatever the time frame is, they're still not letting us know about this stuff that I'm actually talking about today. So we can go on to the next page number 3, Brendan, as we move along here. Now, what we're talking about here on on page 3 is so Paul's theory is that the galactic center is not a black hole, it's a mother star. Now, we are ultimately connected to this mother star in many ways, including with our aura. Our soul is literally connected to it with a silver cord. That's something that came out in one of my Akashic readings. So cosmic gravity waves constantly passed through the substance and impacted some energy to it. He speculated that the rock might act as a rectifier, converting a portion of these energy fluctuations into DC potential. So what I'm talking about here is actually not Paul, although he might have mentioned this in his books. This is John Hutchison. And John actually had something called a rock battery. And I literally watched, I wasn't there, but Carmen has known John for like 40 years. I saw a video of John going out into his alley. He lived in Vancouver, British Columbia at the time. Went out of his alley, he grabbed some rocks and stuffed them in this container, tightened it up, and then he had some kind of a electrical pack. Obviously, it was his circuit design on the end of it. And when he did that, he was able to create a rock battery. Now, what happened was the Japanese came in and scooped it up and bought his patents out on that. So I don't know how far that went. So that's what we're talking about here with John. Now, the voltage maximum occurs when the galactic center reaches the zenith. So essentially what we're saying is the most energy occurs when the zenith, where we're at that zenith point. So going back to John Hutchison.
Whereabouts in the text is this?
This is not in the text. This is, like I said, some of the stuff that's on the papers, it's on page 3, sorry. But this is not in Paul's books though. So
yeah,
that would be just below the DC potential. Note the next page, I think.
That one?
Yeah, that one. So yeah, I'm talking the voltage. So if you go, I'm about the middle of the page now. Yeah, right in there. So John Hutchison, where it says John Hutchison. Sorry, I can't read I can't see that. John Hutchison, he used high voltage, he used high frequency longitudinal emissions using a Van de Graaff generator and 2 or more Tesla coils to create the wave interference zones. So what John did in all his brilliance was he knew that there are interference zones of where there's lots of energy and then there's less energy and lots of energy and less energy. And he was able to calculate those and position all of these experiments in the proper zone so that he could take care of or take advantage of these interference zones and create more of an effect, essentially. So we will talk a little bit more about John as we move on here. At the very bottom of the page there, Brendan, we talk about an excellent book. I actually have it right here. Legia was so kind to find it for me, and I bought it. And then I think we got another one. Legia bought another one for herself. This book is excellent. It's called Lost Science by Jerry Vassilatos. And what we're going to talk about next is we're going to get into the Philadelphia experiment. Jerry says
do you want me to bring up another document, or are we on the right document? We're on the right one?
No. Yeah, we're on the right one. It's just at the very bottom of that.
Oh, okay.
Yeah, right there. So Lost Science by Jerry Valasatosis, I might have said that wrong this time, says the cloaking effect was a very intense pulsing electrostatic field. So this is really important. So now we can go to the next page, Brendan, which is the back of page 3. And it should have a picture of the tank on it.
That one?
No, I think the next one. That's the one we just did.
That's the one I should have shown. So
Yeah.
let me just copy this one and show this one, and then people so that people can, because I think I
Yeah.
got like mixed up. So people can just see it in the recording.
Yeah.
Um,
So at the very bottom of that,
so I'll just show this one. So that's the one that this is the one that Eddie's been talking about, and I had the other page. I had the wrong page.
yeah,
Okay,
yeah.
so here it
And
is.
we're
Here, whoopsie, whoopsie. Let me just put it here. So like
sure.
that, so people in the recording can see it.
Yeah. And at the very bottom, we're looking at this lost science, and this is going to segue into the next page, which is really
Yep.
cool.
Okay, then let's
So
go to the next page now. So,
yeah, so like
um,
it says, Jerry says that the cloaking effect was a very intense pulsing electrostatic field. So remember the electrostatic field part. So now we go on to the next part. So this has actually got to do everything to do with the Philadelphia experiment with teleportation and time travel. So Vassilatos says the invisibility effect was noticed by a classified military arc welding facility. So they were using extremely high current, amperage current to do this welding. And they just noticed this effect. And this is probably back in the, if I had to guess, I might say in the 30s or 40s, maybe, somewhere back then. So yeah, so the invisibility effect was noticed by a classified military arc welding facility that had developed a spot welding technique process employing a very intense high amperage discharge from immense bank of high voltage capacitors. So they're using very high current and very high voltage. So lightning-like discharges cause shock waves and an optical blackout region around the arc, and tools left in the facility of the discharge were displaced or found to have vanished. And that literally is local dematerialization of objects when something like that happens. And why we're talking about this is because it led into what's called Project Rainbow. And this was before the Philadelphia experiment. Now, I'm an expert in the electronics of both the Philadelphia experiment, Montauk, and Wardenclyffe. And as we go through these papers, we're going to actually explain exactly how Wardenclyffe worked, as a matter of fact. So you can see what they did, and this is Project Rainbow. There's a tank in the middle of all these capacitors that are all the way around the whole thing. Now, the ring of capacitors were oriented so that the plates were parallel to the circle circumference. So it just had to be all the way around. Their polarization axis is directed towards the center circle. Then they synchronized it and energized it with high voltage, high amperage pulses, conducted in phase, and this is super important. All those things had to move at exactly the same time. The timing was ultra important. So in phase, along a spoke-like array of in phase along a spoke-like array of cables extending from the center of the ring. Each of the capacitors with the negative potential in the ring's interior. So remember in the first drawing where I showed that the negative,
like that
if
one,
you applied,
that there.
yeah. So when you apply the force, it goes in the negative direction. So essentially what they've got, if you can go back to that, Brendan, for a sec, that just let's show that, scroll it down again.
Yeah, okay. So this one here. Yep.
Yeah. Okay. So or well the other one on the one that you showed at the beginning, but the very top, yeah, that one there. So if we apply the voltage, that thing wants to move in the negative direction or fall into the well of the negative direction, and that's how that wheel turns. Well, the same thing happens with what they're doing here. The capacitors, very special capacitors, have to be oriented so that the negative is facing towards the tank. And every one of those needs to be pulsed exactly at the same time to create this kind of compression, essentially. So that is literally how they first did the Project Rainbow, which turned into the Philadelphia experiment, and then the Montauk project is all related to that. And of course, Rebecca Rose, my friend, was part of the Montauk project. So I've talked to her at length about a lot of that stuff.
I'll bring up the next one if you got it. If you got it.
Yeah, so we're on to page 4. Now we're back into more of Paul's anti-gravity propulsion and other people's anti-gravity propulsion. So it appears that he was cyclically varying the voltage potential across the plates of this electrokinetic apparatus at a frequency of around 750 megahertz to maintain a high thrust condition. I think that is actually from T.T. Brown. What's really important here is the 750 megahertz. The effect doesn't really happen until you get up higher into the frequencies, and we'll get into that a little bit more as we move along in these papers, essentially. So now we're going to get into, I had described the APEC guy named Drew, who's got a mission to Mars. He's going to get there in 8 days. This is the information that I sent him, and this is specifically what we talked about. So the thrust to power ratio was almost 5,000 times that of a jet engine. So this is really important. This means that this is ultra, ultra, ultra efficient. Consider the usefulness of this technology for spacecraft. And I'm pretty sure these are Paul's words. Suppose that a high K electrokinetic thruster was able to achieve a thrust to power ratio of 70,000 newtons per kilowatt. Now, this next part is really important. I want to describe something to you guys. We're going to talk about a power supply of 3,000 watts. Now, what does that look like? Well, if you think about it in the terms of a generator, you know, that you would use to power up your house or whatever you're doing with it, a 3,000 watt generator is not a really big generator. It's kind of a medium-sized one. It might be like 2 feet by 2 feet by 2 feet, something like that. So what we're talking about here is using a 3,000 watt power supply to make this work. But I want to describe something. We're going to talk about getting to Mars in 5 days using this technology. Now, I did the math on running a generator for 5 days, 24 hours a day straight, how much fuel that would be. Well, even with fuel prices of today, it would be a couple $100 worth of fuel. So not that they're going to use a generator running on gas to get to Mars, but this shows how efficient it is. So with less than $200 worth of fuel, we get to Mars in 5 days, literally. So
Yeah.
this is how efficient it is.
Eddie, can I ask you a question?
Sure.
So
yeah.
I was watching a video of someone talking about I think it was that UFO that guy who's a chemist, a biochemist. You know, what's his name? The guy who's who's had ET contact, and he's when he was much younger, and he's talked about UFO. He talks about UFO disclosure and things like that. I've forgotten his name now. Dolan, something. I can't remember his name.
Okay, that's all right.
He was saying that because he's a little bit more on the conventional side, he's talking because he's coming from the mainstream science. He's talking a bit more on the conventional side of things in terms of astronomy and relativity and speed of light. And he said that if a spacecraft was traveling close to the speed of light, a hydrogen atom the force of the hydrogen atom would go right through it or cause a serious damage. Does that make sense to you, or doesn't he know what he's talking about? He said if you're going at the close to the speed of light through vacuum, a hydrogen atom would blow a hole through the he said that. I mean, that may be just conventional.
Yes. Okay. That thinking. I mean, it could happen.
Be a shield. The ship could have a shield.
Yeah, exactly. We have this shield around the ship, so you're enclosed in a bubble. And actually, with a real ship, there's one shield, and then there's an inner shield where the people are, because you have to stay away from the propulsion system. So I think, I don't think he really understands the whole concept.
Yeah, and also Paul's physics is different. I
Yeah,
mean, with
exactly.
the Paul's physics, you can. I think in the CERN experiment, I think it's length contraction that in the CERN particle physics experiments or wherever it was,
Right,
they had they weren't getting. They thought that the atoms would pancake when they got close to the speed of light, and they didn't.
right. Well,
I can't. I'd have to check. I'm not
they
100%
don't.
sure on that.
Okay,
It was
what?
something like that.
Why?
And Paul wrote in his book that special relativity, so Paul's subquantum kinetics has some special relativity effects, but he interprets them differently, and some of them he doesn't. Like I think length
Right.
contraction and time
Well, what?
dilation is just the ether wind makes it
Yeah,
appear to the time dilates. Time doesn't
yeah.
dilate. The
That's
ether
a really
wind makes it
important
appear
point.
to dilate.
That's a
And
really
also
important
length
point. Yeah,
contraction. So they're expecting these atoms at high, close to the speed of light to pancake with length
yeah,
contraction, and they didn't. So
yeah,
that was a special relativity that didn't
yeah.
happen. So
Well,
anyway,
also remember they're within that shield. Like if we're talking about a ship, also that bubble. So moving on here, we're going to talk about how this actually works. So what we do is if okay, suppose that a high K electrokinetic thruster was able to achieve a thrust to power ratio of 70,000 newtons per kilowatt, energized by a 3 kilowatt power supply, which I just talked about, a bank of 6,000, so it's a lot of capacitors, and asymmetrical capacitors. I cannot stress how important that it is. They have to be asymmetrical capacitors. A bank of 6,000 asymmetrical capacitors could develop a thrust of 210,000 newtons, enough to propel a small 100-ton spacecraft, which is like the size of a semi-truck and the weight of a semi-truck, to Mars in just 5 days. So literally, with this technology, we can go to Mars in 5 days. So this is very, very important. So going on to the next page, these are Paul's words, but he's talking about T.T. Brown. And I cannot again stress how important this next section is. This next section actually talks about almost everything. So a definition of the electrogravitic force might be the ponderomotive force, and that ponderomotive force comes from T.T. Brown, a ponderomotive force developed within a high K dielectric under electrical strain. So what we do is we push these dielectrics to the point of them actually probably almost wanting to explode. We put electrical strain on them, and this is really important. That's that you understand the electrical strain part. The patent teaches that the use of nonlinear electrical fields, such as those internally developed in truncated cones of a dielectric material. So now we're talking about a dielectric material that has tapers or angles on it. And again, this is really, really important. There's a couple drawings at the very bottom of that. Maybe you can go to the bottom of the page there, Brendan. And part of the thrust developed by Brown's electrokinetic apparatus would also have been produced by unbalanced electrostatic forces acting on the charges on the capacitor plates. So what I'm showing you there in two different drawings are two different shapes, and how the unbalanced electrostatic force or electrostatic repulsion forces act. And essentially, it is about the shape. You can use other shapes, but what is important is that there's a taper or angle, or as we would like to say, I call it a gravity gradient. And that's something that was recorded with Stevati Aerospace when I did the theory with them. So for a given, so we're talking about these plates. So for a given voltage differential, high K dielectrics are able to store up more electrical charge on their end electrodes. Brown found that the thrust on his saucer, because he had a saucer that spun around, varied as the square or cube of the voltage. So that square or cube of the voltage is really important, because it doesn't take much voltage to create a lot of force once you start talking about squaring and cubing it.
And what's
The
important about the shape of these these
that that
discs?
that you create a gradient. Like you know how they when you're doing the two-dimensional soliton Turing wave simulations, which you've already achieved, there has to be a gradient there.
Yep.
That's exactly what we're talking about.
Electrogravitic electrogravitic gradient, is that right?
Yep.
Yeah.
I call it a gravity gradient, and that's
Gravity
actually
gradient, yeah.
the gravity gradient.
The charge is producing the G well. So the charge is creating is because of the relationship between charge and gravity and mass.
Yep.
The charge is creating the gravity.
Yeah. So there's an unbalanced force created, and that unbalanced force causes the ponderomotive force in that direction, essentially. So it's about creating asymmetrical capacitors do it. We always have to think in terms of asymmetry. Everything has to be asymmetrical for this stuff to work. If you want to draw energy off the ether, you use asymmetry to do it. And that's exactly what's happening here. Exactly what's happening here, right? So
also
actually, I have a question myself,
sure,
and I feel like this might be a dumb question, but it's related to the shape and why it's shaped that way.
Right.
Is it in relation to the waveform, like sawtooth wave versus sine wave?
As we get into it a little bit more, it is related to that. What actually happens is we're creating a soliton. A soliton is created. So and a soliton is a standing wave between the shield and where it's being emitted from.
Paul was also talking about the what's the majig? The his what's the name of his electrogravitic project?
Yes,
the Aquarian device. He was saying it was creating a large.
Elevator.
It was creating a large soliton particle.
Yes.
Around the
ship.
So
as we dive into these papers, we're going to talk more and more and more about solitons, because at the end of the day, that's exactly how Wardenclyffe works as well. How Tesla was.
I'll just quickly show people this the soliton particle that we've
absolutely
that we
beautiful.
That Paul said this is the most important simulation that summarizes his whole work. Basically, he says.
And I'm going to make a prediction right now. Before we talk about that, this is in 2 dimensions. I predicted the other day and told Amber that Brendan and Amber were going to be the 2 that crack the 3-dimensional code and make this in 3 dimensions. So you can see as it forms, the dotted line in the middle
is the X. The yellow one is the Y, and the smaller one in the middle is the gravity. But the X one has been divided by 10 to fit it on. It's actually much bigger.
Yep, exactly. And this is beautiful because this is how come it says in 3 dimensions there?
Yeah, that they want to, because the 1-dimensional one is sharper, is a sharper peak, and they wanted to although so it's we were confused about that for quite a while at the beginning when we first started the meetings, the group.
Very, very cool. So this is Brendan's work right here. Basically you developed all the code.
Matt Pulver produced a simulation, and I just ran the code. So it's Matt Pulver's
so Brendan intuitively found the what am I going to say? It's the input information to make that happen, because it only happens under certain circumstances. Can you talk a little bit about that, Brendan?
Talk about what?
Well, it was you intuitively finding the proper parameters. That's the word I'm looking for, to make that happen.
Yeah,
it only works under certain
parameters. Matt Pulver found
the
parameters. So Paul Laviolette said that Matt had told Paul they're finding the parameters to get this neutral particle, soliton particle. It's like looking for a needle in a haystack. And we've thought about trying to find an electron and a proton, but we haven't had the ability to do that yet. We just worked with this because we can work with this. So Paul then thought maybe the proton happens because I mean, it may be possible to get the proton and the electron, or this is just a simulation of a neutral subatomic particle, a bit like a neutron. It's not the actual neutron. It's one that we're working towards that, but it's very similar to, it could be the neutron. And the electron would, according to Paul's work, will be a certain form. It will be a negative particle. Neutron is a neutrally charged particle. It's a neutral particle. And a proton is a positively charged particle. So Paul was thinking maybe, well, this is what I understand what he's saying. He's saying maybe the neutron came first, and then the electron and the proton came from beta decay. So you got the neutron decays into a proton, electron, and an electron neutrino, and a neutrino, which is electron neutrino. So I'll just quickly get that up to show people. So
that, yeah, very cool. And this is why I feel that this is really important to do this with the Starburst Foundation, because we're always trying to work back towards Paul's theories, and because Paul was a genius. I had a little bit of contact with Paul. I let him know about Stavati Aerospace, and let him know that the theory of anti-gravity was posted with them. I did say to him one day, I said, "You, sir, are the second smartest man to set foot on terra firma," of course, Tesla being the first. And that's when I nicknamed Paul Tesla 2.0, because his theory of subquantum kinetics finishes Nikola Tesla's actual work, in my view. So you can keep looking, and maybe I'll just keep going. Oh, there. Thank you.
Well, this is like a whoopsie. This is quite an important diagram as well. It shows how particles are formed. I don't know if you can see it, or that you can see it there. So that's okay.
Yeah,
so,
I can.
And this is also in 3D, show the X and the Y.
Yep, exactly. So that's the simulation you guys were working on.
This is one of the other simulations that Matt Pulver did.
Yep.
And so Matt Pulver worked with Paul between 2010 and 2013. And he was like a top of his class in mathematics. I think he either did maths and physics together or separately, and he was top of the class. You know, so it was
perfect. Okay, so
this is the now. What am I looking for here? Let me just search under what's the jig? So neutrino. Here's beta decay. So this is beta decay here. Can you see this? This is beta decay. So Paul was thinking, I think Paul was thinking, if Matt Pulver could only get the neutron, maybe that's how matter comes into existence. I mean, this is what I think he was thinking. He may not have thought that, but he's showing that he emphasized the neutron in beta decay goes to a proton, an electron, an anti-neutrino. I think that's there's an anti-neutrino and a gamma and a photon.
Wow, that's so. What page is this on again?
He's thinking maybe that's how the proton electron come about. You know, so anyway.
So this is in the 6th edition on page, I think it was 69 or 75. Okay, perfect. So to summarize, electrostatic forces on the plates of a capacitor become unbalanced when, and this is the important part, they become unbalanced when the electrical charge intensity varies non-linearly with the distance between the plates. The net thrust increases as the field non-linearly increases, in accordance with the teaching of Brown's patent. So Brown did work with DC, and then he worked with DC and then AC on top, and that's called bootstrapping. So
this is quite an important diagram because it takes a little while to get at first when you're coming from the conventional and looking at Paul's work, you're thinking you're a bit confused about what's going on. It seems simple, but you can't. So it's simple, but if you've been taught in the conventional way, you kind of like you're not quite sure what's going on. And then when you see it, it's quite simple. It's very simple.
yeah, so there's the gravity well, particle gravity well on the right-hand side, and the gravity fluctuations. So what page is this on in the book?
This is on 67.
67. That is awesome.
So you can see how this is like the vacuum or the ether steady state. So
Yeah.
so a homogeneous kind of like vacuum state where there's just the ether but no particles. And this is the beginnings of a creation of a particle, and then the particle being created. You can see the particle is a wavy line. So that's the beginnings of it being created there.
Great. And there it is there.
And there's a bit of subtlety in what he's saying, but once you get it, you realize it's quite simple. Paul
Yeah.
once said to me, it's easy to understand, but if you've been taught in the conventional way, you know, it's a bit confusing because you haven't gone to a school where they've taught subquantum kinetics from the early years, you know. So it's a bit
well, that's what hopefully we're
when you see it, you realize it's very simple. But
yeah. So so what he did is he proposed applying an AC voltage across the high K dielectrics of his thrust producing device. And I'll tell you, when T.T. Brown did this, he literally, everything went black. Everything went black. And this is at the very end of the 50s. The Navy, I think he was working with the Navy. And when they saw what happened when he applied AC or bootstrapped it, they just said, okay, this is over. This is going black and nobody's going to know about it. And we didn't know about it till now, essentially. So he proposed applying an AC voltage across the high K dielectrics of the thrust producing device by rapidly charging and discharging his vertical thrust electrokinetic apparatus within the high frequency oscillating field. So he was using very high frequency, like I said, 750 megahertz and upwards. It works a lot better when you get into the higher voltages, or sorry, the higher frequencies. The higher the frequency, the better that it is, essentially. So
do you want me to go on to the next one, or still on this one?
Yeah, I think we're actually on the other one, the next one. And we're almost done basically for today, because essentially I think we read that one. We might go to the last one, the very last one, Brendan.
Very last one, yeah. I think I found one here. I think this one. So let me just show it. Is it this one here?
It's nope, the next one, I think.
That one there. So have you talked about this one?
Yeah.
So I'll just quickly show them. I'll just quickly show them the things so they can.
Yeah, you betcha.
Okay.
And for anybody out there that sees this and wants these papers, certainly they can contact the Starburst Foundation in Brandon, and we will absolutely send them to you. Yeah, we're on this one here. So this is the last part of today. We're only going to do 10 pages at a time. So it's talking about Brown again. He was applying radio frequencies or these megahertz or even gigahertz. It works better like at 1 gigahertz or 2 gigahertz, but these higher radio frequencies, because that's what they actually are. He was applying radio frequency AC and in addition to the high voltage DC bias potential. So what he was doing, if this is the DC here, he was putting AC on top of it. Now, what's really important about this is called bootstrapping. So I designed vacuum tube amplifiers, and with the big power triode that I use, the 845 triode, which was designed by Nikola Tesla himself, actually, as the best audio tube ever built. Essentially, what we do is we have 1,000 volts here, 1,000 volts here of DC, and then we put AC on top of it. So if I put like 2 volts of AC on top of it, now I actually have a potential of 1,002 volts of AC. And this is really, really powerful stuff. So This is when electrogravitics goes black. When Brown began working on his AC electrogravitic resonant concept, they just shut it all down. And electrogravitics is the science of controlling gravity. That is literally the terminology for electrogravitics. So that kind of concludes going through the papers today. Before we stop the recording, is there anything else that you guys want to ask or questions or anything from Amber or anyone?
I don't know if this is a stupid question, but I'll ask it anyway.
Sure. No question is a stupid question. Yeah, no.
I can always edit it out later. But
No editing allowed. No editing allowed. That's your
um,
rule.
yeah, true.
Sorry, go ahead.
This is well, this is from earlier when you were talking about the mother star at the center of the galaxy.
Yep.
Is that the same one that Dan Winter refers to when he talks about the mother star? Or is that a totally different?
I don't know, but I would assume yes. Because
Okay.
I haven't heard it from Dan Winter, but absolutely. The
He
mother
has
star.
like he has like a thing that it's like an actual kind of model that he made of it that
Okay.
he opens up and he actually sells it on his site. But it's really cool because it's a geometrical model of it.
Well,
And
we should get that and have a look at it.
I think he calls it a dodecacosa or something like that, but I could be wrong. But anyway, I just wondered if that's what it is because that would be a great visual aid, I think. If
Yeah, beautiful. Yeah,
we'll
we'll have to dive into that and maybe even I might even purchase one of those. So it's a
yeah,
physical model like that you can
right.
3D.
And it collapses and it opens up. It's really cool.
Okay, we'll definitely check into that because
Yeah.
yes. So yeah, Paul's theory was that it's not a black hole at the center. A little side segue, and it does relate to all this. I had the honor and the privilege of knowing the administrator of White Lake Radio Observatory in Canada personally. She was a family friend, and I had the run of the place, which was fantastic. And one day, and this is during when what is it called now? Sorry, I just lost my thought. Stephen Hawking, when Stephen Hawking wrote his book and talked about how it was a black hole at the center of our galaxy, but there was this Hawking radiation that was released. So this Hawking radiation is actually the super wave or this energy that Paul talks about coming off the galactic center. But where I was going with this story was the radio observatory, Erica was her name, the administrator. One day she had scientists from all over the world coming to talk about black holes. It was a black hole thing. Hawking wasn't there, but it was during Hawking's time, and all the people that knew Hawking were there. And they're going through this, and the guy's saying, he said at one point that nothing can leave a black hole. And I stopped and I said, excuse me, and I don't know why I said this because I got in a lot of trouble for it. I said, excuse me, but Hawking radiation, because I didn't know about Paul's theories at this point, comes out of a black hole. And the guy, he was actually quite pissed off. He didn't know what to say, so he closed his book and he said the lecture is over. And there were like 30 people from all over the world that were listening or waiting for him to talk. And at that point, Erica looked over at me with this kind of like angry look, like, what did you do that for? And later when I talked to her, I said, Erica, she said, why did you say that? And I said, Erica, because what he was saying was not true. We have this energy that comes out of the galactic center. Now, when I had my Akashic reading done with Miranda, she talked about how I had a very, very strong connection to my higher self, but there was a silver cord that went from my soul to the galactic center. So I would say that when we're looking for consciousness, when we're looking for even energy, it is coming from the galactic center. It is our mother star. We cannot do without the sun, but we can definitely not do without the mother star. It is literally it's the consciousness of the Milky Way, essentially, is what it is, along with the heliosphere that would surround it. Because just like our sun has a heliosphere, a sphere of influence, the whole Milky Way also has one of these as well.
It's like the fractal consciousness.
Yep, absolutely. That we talk about in in the other groups, right? Yeah, absolutely. So
Yes.
it's digging into these papers of Paul's, what we're describing is how to make free energy work. How do we actually draw the energy off? But most importantly, we're going to talk about solitons. And we create a giant soliton between the Earth antenna, which I have actual data on from Dr. Schwartz. He shared it with me, and the dome. And we create a soliton between those two, and we are able to draw energy out straight off the ether with it. And that's exactly how Wardenclyffe works. And I think maybe the 7th or 8th show, because there's 8 in total, we're going to talk about exactly how Wardenclyffe works. But it's all about creating these solitons. So when Amber asked the question about, is it a wave, that goes from that point to the rounded surface? Absolutely. What we're doing there is we're creating a soliton. Now, it's easy to say that, but what is hard to do in practice is to tune your electrical setup or whatever apparatus you're working with to create that soliton. So it requires very, very fine tuning and lots of knowledge of a lot of different things to make it work. So it's easy to say in practice, but it's extremely difficult to do. But as we move through these papers, we're going to explain absolutely everything about how it works. And that, again, is why it's very important for me to get these papers out. And I'm very thankful to Brandon and everyone with the Starburst Foundation, Theo and Mariana, especially Paul's wife, that we're able to do this today. And we will continue doing this. And what we're going to do is we're going to share this with Legia, and Legia is going to put it on her potentials.
I'll put it on Starburst Foundation, and
yeah, we'll put it on Starburst Foundation.
On etheric.com.
Yeah, and Legia's going to put it on her Patreon channel. So there is already stuff that we've done. We have actually done 2 shows already ourselves, but we're going to call this the Starburst Foundation Subquantum Kinetics #1. And then if we continue with that exact title, then it'll be easier for people to find, especially in Legia's stuff, because she's got so much information there. But I really thank everyone today. I thank Brendan, and I especially thank Legia for everything that she's done, and looking very forward to getting this up on her channel.
Thank
you. I just want to say thank you to you too, also to everyone, to Brendan and Amber and Jeremy and Ed. Thank you for allowing me to put this on my channel, and for putting this out there for everyone that is interested and is a member. I really do appreciate that very, very much. So thank you.
Yeah.
I just wanted to express
Absolutely. I'm happy to
Absolutely.
help.
And I just wanted to say this, that last meeting, Mariana, Paul's wife, was with us, and you should have seen how tickled pink she was, and the giant smile on her face when she started talking about the girls that are involved with subquantum kinetics.
Yes,
And Amber,
she was very happy to see me there.
She was beaming, and I think she understands that Legia is a big part of this, because Legia and I have actually been doing this for, I think, at least 9 months, talking about subquantum kinetics a lot in the other groups.
I could make I just had a thought of an idea. I could make what's the majig? A Facebook group page for SQK Social Society, if you like.
Oh, beautiful.
Do that and see what they see,
Sure. The more out there, the better. Yeah.
Great idea.
Can you also do that on LinkedIn as well? Is that possible?
Yeah, I can do that on LinkedIn. I'll write it down.
Beautiful.
Facebook.
Yes, please.
Facebook.
Beautiful. That's awesome, you guys. Because the more people know,
LinkedIn. So
better.
that's a LinkedIn page, and I'll work out how to do that. Yeah.
Yeah.
Okay.
Perfect.
It's a great idea. Yeah.
That's an awesome idea. Yeah, I love it. And of course, Paul would love all of this. And seeing she's so beautiful, and seeing her beaming smile last week, was just truly amazing because she was so tickled pink again that the girls are involved with some quantum kinetics, and both
Well,
of you
maybe
are very involved with it.
maybe we can get her on one of these.
We absolutely will.
That would be awesome.
Absolutely.
Yeah, I don't know if it's Amber or Brendan or who needs to talk to her about it, but that would be fantastic. Yeah,
Yeah.
absolutely.
Well, this is very exciting. So
yeah, hopefully Mariana will come on here. Yeah, but
Yeah. Could you ask her, Brendan?
Yeah, I think she'd like to come, especially if there's Amber and Linda on as well. Her English is kind of portable. It's getting better. I think she can understand more than she can speak. She can speak a bit. It's kind of poor to moderate. So sometimes she can speak quite well. Other times, whatever, you know. But
this is kind of funny. I just want to say that last time, Jeremy in the chat had said, I think he said, I don't want to be that guy, but who showed up with the Russian the Russian name?
Sorry, just to me, it did look that way, but
and it was funny because I knew that it was her, but I didn't say anything. and then she appeared, and yeah, that was super funny. I just wanted to bring that up because humor is a big part of exactly what we're trying to do here too, right? It was super funny. Like her name that was probably in Greek, maybe, perhaps.
Yeah, it probably was. Amber told me about it after the fact.
That's perfect. I love it. Love it. So if does anyone else have anything to add or any more questions before we stop the recording?
I think you did very well, Eddie. Well done. And also Lydia, Amber, Jeremy. Yeah,
and
very good.
Everyone. Yeah, thank you.
And
thank
you too, Brendan. Absolutely. Thank you for sharing those beautiful graphics with us, Brendan. That was awesome.
Yes, that was helpful.
Thank you.
Yeah, Brandon is the computer, literally. He's able to go into the 6th edition. Mind you, he's the one that's actually editing the 6th edition for us. We have to give him
those visuals are so key for a lot of people. That's how I learn.
Linda, I'll send you a free copy.
Awesome. Wow. Thank you so much.
And also, Amber, I don't know if you've got it, Amber. I'll send you one if you haven't got it already. I'll make sure.
Go ahead and send that to me because I don't know if I got it.
I'll send it to you as it is now. I mean, I just when I complete it, I'll send you the complete one as well.
Okay.
Yeah. Because he's just working on the index, I think, right, Brandon?
Yeah, I'm working on the index. I was taking a bit of a holiday after that little schism with a couple of weeks ago. And the group schism, which turned out better than expected.
Well, the schism led to
good things came out of it. I was kind of like, so I just went into it yesterday and just did a few things I was just going on Stack Exchange and asking questions, editing things and questions in chemistry and philosophy and in physics.
I'm sure that takes a lot of work and a lot of time to do. So
it's a full-time job for
you put a lot of work into that. So yeah, much appreciated. Definitely.
Thank you.
Yeah. All right, everyone. Maybe we should stop the recording at this point, I think.
I gotcha.
Yeah.
Ciao
and thank you, everyone.